Hello, everybody. I'm Pau. For Citrix on the Xenserver or Citrix hypervisor on the tool stack side, which is the control plane, and talking about the adding TLS verification to this product and the history that got us here in the evolution. So Xenserver is a distributed system that offers resources to VMs, and it's based on Xen and the Zapier project. It has some advanced features like giving access to the NVIDIA virtual GPUs to the VMs and GFS to clustering. And one very important thing with the distributed system is having the secured pool communications. And this is done through the XML-RPC protocol using over HTTPS. So the connections are established on the both ends. When they get established, we have the clients get verified by the server using a shared secret password, but the client doesn't try to verify the server, so it might establish a connection to an unknown server, and that's a security problem because once they have the shared secret, they can access all your system, which is something that we really do not want. So in the beginning, in 2016, we established these TLS connections. Before they had also SSL V3 connections. We used S-Tunnel, which is a program which basically acts as a proxy from an HTTP that Zapier creates, the HTTP server, and to the other end on the other host, we have two S-Tunnels creating the secure connection. Then for one feature that we wanted to do, which is having a VM that actually load balances VMs depending on the metrics that we report on, for example, how loaded the server are, checking the CPUs and memories. And for that, we need Zapier to establish a connection to that VM, to that appliance. And to do that, we really need to do because it's an external connection, we added support for users to install trusted certificates to be able to establish that connection, the external connection, and that was added on late 2008. On 2012, we added mutual certificate verification, which is the goal that we did here, but it was only done for certification purposes. So it was done because it was only done for certification. It was not a complete solution. We had a way to allow users to do it, but it was all manual. They had to copy files. It was really it was very awkward to use. And in 2012, we added the capability to finally install these certificates and remove all this manual work and be able to install it through the API, which makes it very easy and which unlocks us to do all this. So when the work in 2020, the work that I learned about the certificates, TLS, etc., we actually added some checks for the private keys, for example, and do some checks on the trust roots, on the trust chains of the certificates, the TLS certificates, which helped me to in the end in 20. Sorry, no, yeah. This is we had the first try, that's in 2018, to add this the certificate checking, but it did not come to fruition, unfortunately. And it was planned for 2019, but I don't know the reasons, but it was, I think, lack of resources. And the decision was to be left the product as it was before for the CC certification. So what the plan was to add a pool to act as a CA, So basically, we would add some mechanism here to sign certificates for host certificates that they display to the clients. And so what the mechanisms basically is that they share this certificate, this private key, and they sign their own certificates, and they all have this trust root, this certificate where they sign each other the certificates, and that's how the trust root gets established, and they trust each other. There was also some plans to maintain the revoked certificates, the list, to be able to know which, in the case where some certificates got revoked, to just not use it. But it was quite not quite done, and it missed some things like the WLB, what happened with it, or for example, how to do certificate cycling and how to replicate the actual certificates, because the private certificate, the root certificate, there's no, I mean, once we have the case where a join gets removed from the pool, they still get the private key. What happens with that? How to cycle this private key. So finally, we got time in 2020 to start doing a new design, and what we did was drop the CA plan, and what we wanted to do is just try to use these certificates, the current certificates, as a way to trust each other without having any sort of change if we could enable it. But because we did allow in the CC mode the users to install certificates, this means that we had to support these two kinds of modes of operations. One using that simple one using the self-signed certificate that come by default in the host, and the other one was trying to make it compatible with the user install certificates. And the problem that this causes is the user install certificates use as a subject, they use the host names. And that means that we have to change the way the connections are established between the hosts, because usually they are done with IPs. But if we want to be compatible with these certificates that use host names, we have to establish the connection using host names, not IPs. And that means we had to change quite a bit the framework or how the connections were made. And it also forces us to be dependent on DNS, and that is yet an unsecured protocol, which is really not what we want. We want something that is more stable. So what's happened is, like, in 7 months, I was learning about more how to do this and experiment and trying to learn. And then we did 3 months of development where we could see that things were ramping up, were getting very complicated. So the beginning of 2021, a partner of mine, Christian did some, I think he was doing some related work, and he found about the SNI part of the TLS protocol, and that is the server name indicator, which allows a server, depending on the request of the client, to serve one, to decide which host certificate to provide, usually depending on the host name. Here we do not use, because it's not, these servers are not exposed to the public internet. We do not. We're going to use it in a different way, because we don't really have host names, but it can be exploited to still decide which certificate to give. And the way it's done on the pool operations, we add to the external the client configuration to add the host to request for a host called Zappy pool, which is static, but still works for us because the rest of the API clients do not need to know about this, and they will still get the full certificate that the user installed. And these also allow us to have the subjects for the certificates used for pool operations to be static, and have the host UID, which is decided at its install time, and plus a serial number. This is because we saw some problems with this tunnel. If we do not have a serial number, they were not replacing the certificate when we told it to please reload the certificates. So this, I think it was 1 week, 2 weeks of prototyping, 1 week of changing the design, and then 7 months of development that we ended up, I think, around September of last year, a year ago already, when we actually enabled the TLS verification by default on all installations, on all new installations. So I think that one of the critical parts of this work was trying to never break communications, and the most critical part where things can go wrong is when the keys are exchanged, the public keys are exchanged for the servers to trust each other. And we made it so that exchanging certificates in all the process, even if it's interrupted, it's not going to break operations. And it's done like to generate the certificates, we distribute that, then we reload all the external servers to change the certificate provided, and at the very end we can delete the previous certificates and we clean up the file system. And basically means that the old certificate is invalidated because it's not going to be used anymore, doesn't exist. So the critical part is on the pool join when new hosts join the pool. It has some special operations. Basically, it's when the trust is established, and the way we decided to go is basically at the very beginning there's a connection being made and some checks being made, and this is done. It's not the connection to the server, so the joiner makes the connection to the pool, and that connection is not being validated at that moment. It's just on the basis of this is the first time that it's being set up. We just trust it. We just trust the network. But as soon as we have the pre-checks and the certificates are exchanged, we switch to a trusted connection, to a verified connection, where we do the normal proceedings of the pool join, where we replicate the SRs, the storage. We set up the storage and we set up everything else. And yeah, the beginning of the process, the joiner is forced to restart, and then it restarts as a pool member, where everything has been set up, all the certificates, and usually it just works. In some cases, however, there are multiple joins that are being held in parallel. We might have missed one of the certificates that the other joiners were exchanged. So then we forced to download all the certificates that the pool has, just in case that means we're not going to get the connection interrupted. And because enabling all these certificate exchange we don't want it to go wrong, basically. Then to be able to enable this new operation, the certificates need to be exchanged, and in some cases that it might be dangerous to do. In one of the cases on the pool upgrade, because we upgrade one host by one, that means that the first host to be updated is going to be the coordinator, which has the database, and the rest of the members of the pool will not have generated certificates. So that means that until all the hosts are updated, we cannot switch it on. And the other occasion where it's just dangerous to try to enable it is when HA is enabled, which is a mode where hosts, when they have bad connections, for example, they might fence, they might restart, and we do not want to put the pool in such situation. So instead, we decided to make to let the user, once they are ready, that they know there is no operations going on, they can enable the TLS verifications, which will do the exchange and then enable it. So this exchange, we do some checks on it just to make sure before everything is enabled that it actually works. And we do n-squared connections between all, so we check the connectivity between absolutely all the hosts in both ways to make sure that everything is okay before actually enabling it. So one thing when doing the coding that was not in the design was basically how to track down all the usages of when we actually made connections to another server, how to make sure that there are no unverified connections, unverified usages, because our code base, I think it's more than 400,000 lines of code. So it's not that easy to hunt that down. So what we did is, using the camel type system, change the library that generates the external connection, the external configuration, and does the external connections, and change it. So there is a variant that allows us to choose whether there is no verification going on, or there's external verification, or there's a pull verification. And Camel helps here a lot, trying to just giving compiler errors and type errors to try to find all the cases where this was happening. I found quite a few unexpected places where this was happening. So I was, very glad that we used the kernel here to fix this problem. And then we added a quality gate in the CI that counts the usages of the unverified connections, so we can hunt them down and reduce them to 0. And to support this, this use case, to have it more complete, what we did is, before the 2020, in the 2020 change that I mentioned about installing nicely the certificates, we added the user install certificates to the database, so they are exposed to the user and they can see the thumbprints, the public key thumbprints. And with this work, what we did is add all the rest of the certificates that are installed in the host. This is like self-time certificates and the trusted certificates, all to be exposed through the API, through the GUIs.UC API and the CLI. Then we also allow the certificate checking to be disabled in some emergencies, so it can be recovered from if there's a problem. I don't think we've ever had to use it, and I think we've done quite a good work doing the testing, rollout testing, and forcing, for example, one thing we were worried about were the certificate exchange. So on the internal testing, what we did on normal tests is force it to rotate every single hour to try to force out the errors. I think we found 2 or 3, and fixed them, and after that, we felt very confident that everything was working fine. There were also work about showing up alerts about failed logins, trying to count all the failed logins, where they come from, and expose the IPs, so users can see if they are being attacked, for example, what could be the problem here. And then after the work for this work was done, what we had to integrate the clustering daemon, because it has its own network to themselves, like on all the hosts. And that we did, I think, 6 months more of work to try to make it work. I think there were two designs. The first one didn't quite work quite right. It was too complicated using its own certificates. And what we ended up doing was actually using the certificates we used for full communication, use them for the cluster as well. And being able to reload the certificates that this was using, which is not using external. So that forced us to patch some upstream libraries in OCaml to actually make use of this while not shutting down the daemon and doing while it's running. So for future work, there's still the verification is not done everywhere, unfortunately. On one particular case where that is not done is when the CLI that we have is able to launch remote requests to other servers that are not the local one. And in that case, there is no verification being done. So we would like to have a trust on first use verification, but that is not quite yet. And we also really like to use HTTPS for everything. There are some cases where HTTP is still used, and we could put the external there. One is the VM migrations inside the pool, which should not be too hard. I think Rob has done work and has a working prototype already. Then there's the cross-pool migrations, which need to use, which these two hosts are in separate pools. They need to exchange the certificates. We have methods of doing that to transfer the metadata, and actually the client that actually initiates the connection, we have a design that can provide these certificates to initiate the connection, so there is no inherent trust being done between the two servers. It's all very explicit. And with VM importing and exporting, we've seen that some of the imports, for example, are HTTP only, and we would like to try to use HTTPS and disable this HTTP one. Any questions at all? All right. Doesn't look like there are any questions. No, thank you very much.